Yo, well, welcome. My name is Dr. James Utley, your resident codebreaker data scraper, and I'm here working on a new project. It's called Boltar. It's a Rust implementation of bolts. So basically, it started with this trend of like going down the path of AlphaFold and AlphaFold 3, and I saw that there was open source options, and I love Rust, developing in Rust. And I also love building it myself. So, if you can't build it, then you don't really understand it. So I decided to take on this Rust implementation of Boltar. A lot to do. This is part of a project for how to grow almost anything, which is a cool course that I'm participating in. And yeah, so let's get into it. I'm wearing the Batman lab coat, so you know this shit's legit. And let's go. So it's all open source, all on the GitHub. Check it out. Let's get after it here. I have no idea what's going to happen, so we might be living in the error world. But I already built up this. So basically, I have a startup script that builds everything. So and does kind of a testing workflow and make sure that it's all aligned. And for all you haters out there about Rust, yeah, so you can build shit with AI in Rust, but most of the time the AI agents they don't like the Rust so much, which means they get you far enough along. And of course, I use agents. So the agents I've been using, one is this Composer Too Fast from Cursor, which is a legit model because it's like good for touch ups and stuff like that. If you know some orchestrate and some engineering, and the other, which is kind of my heavy lifting model, which is a coding agent that I designed myself, and this is built in Rust for Rust development, and it's a continuous project. Again, open source. Check it out. It's called Vybrid. Boom. So we'll launch the Vybrid. So that is an AI coding assistant from the trenches built in Rust. Now, it doesn't absolve you from knowing about the Rust compiler, borrow checking, ownership, all that shit. Like you have to know that stuff. And you have to know how, main.rs files and all this, all the libraries that you need. And anyway, but let's kill this terminal, and here we are. All right, so we're gonna bust over, and we are going to kick off. See where this. All right, so here we go. So let me check something right quick, and you are not seeing it. So let me update that. Let me update the screen capture so you are seeing the right window. You know what I'm saying? That's important. All right. Word up. So this is Boltar. You see, it's kind of a funny play on words. Bolt, like bolts, but I threw an R there because it's built in Rust. Boltaire, all of the above work, whatever you want to call it. And so let me just walk you through it. All right, so here we go. There's a lot of text here because it keeps me honest, meaning like I have to, this is a web UI. This is a CLI tool, but everybody loves a web UI tool, or when the shit gets too complicated, you got to use a web UI. And so I put everything here to output so I can just kind of go through and it keeps me honest, which means like where everything is stored, like in the cache. So I had, of course, there's libtorch on the back end. It uses tch.rs, the tch, which is basically Python. It's a C++, it's a Rust bindings for C++ and PyTorch, or in Python. Um, and yeah, so here we go. Now you see that I have it all here in my cache folder, right? And so I do this kind of check here, which means that I have the safe tensors are there. It's cache, the environment, meaning because you kind of have to like manage two environments because I'm using kind of a bridged mirror image of bolts. So you got to have like this Python environment also, and to do so, this is a bootstrapped version of bolts. So bolts one. Anyway, here's the breakdown of everything that's needed and where it's at, from hyperparameters to, and so then I always look here. So my libtorch import. So my libtorch runtime was okay, and the TCH features, which is basically the Rust bindings, or I guess the Rust component, is also loaded correctly. Now, make sure that you're seeing what I'm seeing, and you are. Okay. So this is assume an MSA server. So it's like a sequence alignment server. So yeah, I'm going to assume that. And what I'm going to do is I'm going to grab a YAML file. So it's all based on YAML files. And you see that YAML file is loaded. So that's how you get like
the input is YAML. Anyway, so I validate it to make sure that it's the right, the file format is like a bolts-like format. So it can do the pre-processing, it can use the MSA server and all the stuff that I'm about ready to show you. It also checks to see if there's a JSON manifest or a .npz file, which is like ND array, or that's the REST version. Like, gosh, what's a Python? Not ND array, NumPy. So that's all set up. And okay, so we have all this. We have everything cached. Now we get down to the run predict, right? So first off, we're going to use a CPU, but it has basically two versions, two CUDA kernels that is for the GPU acceleration, which is really unstable right now. So I'm just not going to mess with it. Meaning it's like there's some memory errors on the CUDA side, and just things I got to work out, little like bugs I got to work out. Now, so the output format, you get a couple. You get your legacy PDB file, or you get your CIF file. I like the CIF. So I'm going to look right here where it says some protein chains have no MSA patch used local. These alignment files or run Bolter predict, use MSA server for those chains, right? So, and then it spits out this P. I mean, so you have your chains, you have your like protein chain here, and then you have the DNA. And that's what the file, your YAML file has already outlined. So, all right, you're good there. Okay, so now we have this all set up. You could do just affinity, but then that removes the pre-processing. There's the ability to override some stuff here, which we'll get into. If you want to look at only spike protein only, you can use this feature here. And again, this is like, there's a lot of validation still needs to happen on this, but it's working out because again, this doesn't exist, right? So there's Jack's implementation of bolts or jolts, they're calling it. And so this is the Rust. So it's Bolt R. And you can change your diffusion samples or steps or like how many prediction iterations, if you will. But we're not going to do any of that for this demo. And we're going to run predict. Boom. All right. So if you see here at the bottom, I'll make sure you're still seeing what I'm seeing. Okay. And you are. Word. Is that you're going to have a startup script. That startup script is going to run through and it's going to push, and you're going to see it's kind of going to go through this, which as I walk you through, it's going to look for, so there's built in the GPU and the TPU. And so this only, this machine only has a CUDA GPU available. So it's just true, but we're not using that. So then it's running the prediction for the one input. So this is the one input, the one file, the one YAML file. And then it's going, so if you can see through the file format here, it's like this PyTorch Lightning, right? And that provides a checkpoint, and it gives you, okay, which is newer than your current Lightning version. Oh, okay, because I'm using the older pack, which is fine. And then here, so we got TensorBoard, this PyTorch Lightning, and you just gotta like read the log, and that's, so like right now it's doing some prediction steps, and if you can see here, just kind of like let it cook and go through all the iterations, and so predicting the data loader, and it's kind of cooking through that. All right, and we got an output here. So it says, so this is a structure output, finds it in the file path, which is one CIF. And if you see here that this is a tar, this is a tar file, right? So we're going to download this output, and I'm going to probably have to change screens so I can show you. Let me do that. Maybe all right. Probably going to have to change. Okay, so let me change the screen here right quick. All right, and if you see that you got your predictor file here from that tar.gz file, and so let's go over here and let's open this up. Okay, so this is kind of like your standard output. You're going to get some metadata stuff in the form of JSON. You got your MSA server data, which looks like one alignment of the protein. All right, so I don't think you're seeing that window. And okay, and then you have your protein DNA, your complex model. So you have your CIF file, and then you have your predict complete, which is a text file that goes over. So without getting too much in the weeds and boring you, let's go ahead and run this CIF file in a PyMol. Let's see what happens. Okay, let me get to the right screen here. Sorry for the suspense. And let me run PyMol here on the system. Okay, and while we're waiting for that, the PyMol and Arch Linux is pretty legit. So just FYI. All right, let's go ahead. Yeah, sorry. Let me update this so I can get you to the right window. Okay, the PyMol window. We got you. All right, I'm gonna make myself a little smaller here. Put me in the corner where I belong. All right, and so let's go ahead and open this guy. And let me find the right file here. We got tons of suspense. All right. And then let me find the right one. What are we? 4.3. Let's get down here. Okay. Okay. What happened? What happened here? I think I clicked the wrong file. Which one is this? Okay, 0B. Oh, there it is. Word. That's a strange friggin' thing. That means like the prediction's probably way off. I don't know. All right, so let's smooth this around here. It's like kind of a delay there, but yeah, that's crazy. That's weird looking. So let me see. Let me change it to. Let's do like oh, this thing jammed up. Okay, yeah, bruh, that's strange, super strange. So that's strange. Like there is something just off about this prediction. And let's try the mesh. Yeah, this is just wild. But yeah, it's crazy. Anyway, that's the. Let me make sure that you guys are seeing this okay. We got the window like legitimately sized out. For wild. So anyway, yeah, like I built this thing, man, and I know that do some dots, see what the dots give us. I'm like, really, this is really cool. Anyway, this is Boltar. So we be predicting. So let's see how it all works out. A lot of validation. I'm very grateful that I built this thing to flow and that it can actually predict some things. And I'm not sure if it's not accurate. I mean, it's maybe like partially accurate. And of course, you got to like refine and everything, but that's where we be. So Boltar. So I'll keep you updated. We're gonna validate this. We're gonna run it against other protein prediction models, and we're gonna try to get some accuracy. Eventually, I want to like train in a Rust native library, like either BurnML or something. So then it can be like its own independent Boltz. But I'm very grateful to the Boltz people for allowing us to be open source and transparent and being able to build on top of it, and even build adjacent with bridging and things like that. So pretty legit. And all right.